Hello, this is Aobo Yang's homework 5. So let's see the first question. For the first question, we can say fx is equal to this one, and fyy is equal to this one, and we need to find fz. Best of z is equal to x plus y. And first we use the convolution method. So for the convolution method, fx is like this, and fy is like this, and we shift move the fy background like this, and shift it in like this. So we can get here is -1 plus n, and here is -2 plus n, and we shift this to this side and make it have some cover with fx, and we can easily find that from here to this one equal to 0, there is no any areas covered together, and after this one from 0 to 1, and it can have covered like this in some place, so we can easily find that from 1 to 2, and fz is integral from 0 to n minus 1 to n-1, and the area is 1, so it's n minus 1. And after that, we get then from here to the another side, and it's like move from here to there, and we can get from 2 to 3. We do the integral from n minus 2 to 1, and we get it is 3 minus n. So after that, it move out from the 1, so we can easily find from n more than 3. There is no area, and fz is equal to 0. So we can easily find that fz is like this, and we can write it as this one: z minus 1 u of z minus 1 minus 2 z minus 2 u of z minus 2 plus z minus 3 u of z minus 3. And for the next method is a geometry method. So we can see that for the geometry method, first we can get it from z is equal to x plus y. So y is equal to z minus x, and z minus x. But for the y is more than 1, so we shift it 1 to the right, and it's like this. So here we write z minus 1 because y is more than 1, and we can easily find fz is equal to x plus y, this, and equal then z minus 1, and so we can find that the area is like this, half of the z minus 1 square, and we do the differentiation of the fz, so we can get fz is like this. So the second is, so after z shifts to this, and we can easily get that it's like this, so we can easily find the area together is like this triangle minus this small triangle and minus this small triangle. We can easily get that fz is like this, and the small fz of z is like a differential of this one, and it's minus z plus 3. And for the third one, after z minus 1 more than 1, and that means z is more than 3, we can easily find fz is 0. It's easily to find that. So in summary, we can also get this solution just the same as this one. So for the second question, first we draw the non-zero definition region of fxy. So how to draw that is that first we get x is more than 1 divided by y. So from this section, so we can get that y is more than x, 1 divided by x, and x is minus 1, so y is more than x, and y is more than 1, so we can do that like this, and this, so we can get this one. See, and for the second question, find a so that fxy is a valid joint density function. So how to get a valid joint density function? So it is like fxy is like this. We can easily find that x is like this. And to get a joint density function, is we do a double integral of dx and dy. So after that, we can easily find that it's like this. We get the omega is equal to ln y, and we can easily find y is equal to e omega for 1. And after that, we do an integral for this one, and it is by the way, instead of y is equal to omega, no, omega is equal to ln y. So after we do an integral of this one, and we can easily find it is the final is 2a, 2 times a. So we need to find the value density joint density function. So this order integral is need to equal to 1. So after that, the final 2a is equal to 1, and we can easily find that a is equal to 1/2. So fxy is equal to this one. We can easily get that. For the next question, so find and draw the marginal density function fx and fy. So we can do it by the definition. It is like fy is equal to integral from -infinity to infinity fxy dx, and the same fx is equal to integral from -infinity to infinity fxy dy. So for this dx, we can easily find x is like this area. So we can do the integral from 1 divided y to the y, and then to the all the fxy. So it is the final is ln y divided y square, and we after that we do a integral from 1 to infinity to get it if it's valid for the fourth question. So the integral of this one we can easily find is 1, so it is valid property density function. So after that we do the fx is the same, and but we can easily find that x is more than 1 divided y and less than 1. So we need to find that for the first, x is more than 1 and more than 0 and less than 1. So we can find that we need to do integral from x to 1 divided x. So we can easily find that is 2.5, 1.5. And after that, we do an integral from 1 to infinity. So that is we need to do the integral from x to infinity. That means 1 divided 2x squared. So after that, we can do this in summary. That is fx is equal to 1/2 from 0 to 1, 1 divided 2x squared from 1 to infinity, and 0 otherwise. So we can find fx is like this, and fy is like this. We can easily find that. So, and after that, finally, we do the integral from -infinity to infinity of fx dx. So that means from 0 to 1 like this, and from 1 to infinity like this. We can really find this to 1/2 plus 1/2 is 1. So this one is also a valid property density function. That's all about homework 5.